In this video, I'm going to speak with you about degrees of freedom and how they work in an independent samples t-test. So let's take a gander. So in this section, we're going to look at degrees of freedom, and we're also going to apply to the t-table and to the t-distribution. So degrees of freedom for an independent samples t-statistic is determined by the degrees of freedom values for the two separate samples. So we have a degrees of freedom for sample 1, and we have a degrees of freedom for sample 2. We add those together to come up with a total degrees of freedom. Degrees of freedom 1 plus degrees of freedom 2 give us the degrees of freedom for our independent samples t-test. And we need this degrees of freedom total for our critical boundaries. So a researcher was interested in the impact of a treatment on memory, and an independent samples t-test was used to analyze results. So sample 1 had 8 participants, and sample 2 had 8 participants as well. What are the total degrees of freedom for this study? Well, let's think about that. What are the degrees of freedom for sample 1? 8 minus 1. What are the degrees of freedom for sample 2? 8 minus 1. That gives us a total degrees of freedom of 14. And sometimes when I think of an independent samples t-test, I think of the total number of participants minus 2. In this case, we had 16 minus 2 gave us 14. But it is the same as saying each particular sample minus 1 and then added together. So we're going to think about it just a little bit differently now. If an independent samples study had a degrees of freedom of blank, how many participants total were recruited to participate? Well, think about what we just said. The degrees of freedom are found by finding the degrees of freedom for each group and add them together. Or you can just take the total n and subtract 2. So think about that now. If you need to pause the video, go ahead and write down what the answers to these are. Okay, so if we have degrees of freedom 14, that means that there were 16 total participants. Degrees of freedom 18 means there were 20 total participants, and so on. So for this learning check, you're going to need your t-distribution table. So go ahead and take that out if you don't have it already. We're going to find the degrees of freedom for a study, and we're going to find the critical boundaries using our distribution table. So for this particular study, we had 2 samples, and each sample had 10 participants in the samples. What are the degrees of freedom for this study, and what is the critical boundary if we do a two-tailed test with 0.05 level of significance? So let's think this through. First of all, what are the degrees of freedom for this study? Well, the degrees of freedom for each group is going to be 9, 10 minus 1. So the degrees of freedom total are going to be 18, correct? So I'm going to find 18 on my table. And again, we were looking for a two-tailed test with an alpha level of 0.05. And I've circled that right there. So we draw an imaginary line down to find 2.101. That is the t statistic that's going to cut off the high probability area from the low probability areas, aka the tails. So our degrees of freedom were 18, and our critical value was 2.101. Plus or minus 2.101, I might add. 2 separate samples, each with 21 participants, received 2 different treatments. What are the degrees of freedom for this study, and what is the critical boundary using a one-tailed test with 0.05 level of significance? Well, let's think about the degrees of freedom first. For each sample, it's going to be 21 minus 1. So 20 plus 20 is 40. Or if you think about it, if each sample has 21, that means there are 42 total, and 42 minus 2 is 40. So 40 are our degrees of freedom. But this time we're doing a one-tailed test with 0.05. So I'm going to circle the degrees of freedom of 40. I'm going to find the proportion in one tail at 0.05. And that gives us a critical boundary of 1.684. So there it is. When we had n of 21, our degrees of freedom are 40, n of 21 in each group, that is. And our critical value in this case is going to be 1.684. It's a one-tailed test. We haven't specified if we think it's going to be in the lower tail or the upper tail. If our hypothesis is that our mean is going to be in the lower tail, the critical value would be negative 1.684. If our alternative hypothesis is that it will be in the upper tail, it would be a positive 1.684. Okay, just a quick introduction to degrees of freedom, and in the next video I'm going to speak with you about the assumptions of an independent samples t-test.